All right, welcome back everybody to another exciting session of CE 374U Urban Stormwater. Today we are really entering the home stretch of the course. We've only got a few lectures left. So it's basically just going to be today, 2 lectures next week. You'll go on your fall breaks, and then when we come back, we'll be doing presentations. We'll be doing presentations for your final projects. So we have a relatively short timeline left. I want to give you as much time as possible to work on your course projects. So we're going to be doing that for most of today. But first, I want to give you a little bit of info that will help you with specifically the land cover portion of the project. So I'll do that for about the first 20 or so minutes of class. Okay, a couple quick announcements before we get started. Homework 6 is due next week, scheduled for Wednesday. That homework will comprise your preliminary designs. So I'd like you to have your preliminary designs basically done by that point. And then from that point on, you can move into your final designs, which you'll use for your presentations. And then ultimately your final reports, which will be at the very end of the class. So we'll be working towards homework 6 in class for the next couple of days. But please do come see me and Becky at office hours if you have any questions about the preliminary design so we can help you. Okay. Are there any questions on homework 6? Any questions? Okay. I will be assigning an extra credit homework, as I mentioned before. So this will be a homework assignment on EPA stormwater management model. This will give you a little bit of a chance to get acquainted with that model, which is a really important stormwater model, but not one we have time to cover in this class with our schedule. So that will give you the opportunity to learn how to use the software, and we'll also give you a little bit of opportunity for extra credit if you need extra credit to make up for homework you may have missed points on. A couple more announcements. So we have a couple companies hiring. So HDR is hiring a couple positions related to stormwater and water resources engineering. So this was brought to my attention by Benjamin. So there's a couple of positions available. Just feel free to talk to him about those positions if you have any questions. There's a number of different positions, and also positions outside of stormwater as well. So there's more information on the announcement. And then Austin Water is also hiring a couple of process engineers, and Joey was telling me more information about this. So they are hiring what seems to be, it's 2 process engineers for water treatment and 1 process engineer for wastewater treatment. Is that correct?
Yeah, that's, I think, total. They may be hiring as well.
Okay. Yeah, so I will post an announcement with those positions on there too. So this is more on the treatment side, but still relevant to many of you who are interested in just general water resources. Are there any questions on these announcements before I move forward? Any questions? Any questions on project timelines or anything like that? No? Okay, so before I let you work on your projects today, so I'll let you work on your projects for the majority of class today, and I'll be walking around to help you. I wanted to talk a little bit about the land cover part of the project in particular, because it's one of the harder parts of the project. And I want to give you a sense of basically what land cover modifications you can make and how you might go about deciding where to put those modifications and how to model them. So today I'm going to give you a quick run through of different green infrastructure or low impact development options. This isn't going to be a very detailed lecture on, the different technologies themselves, but rather how they apply to this project in particular and how you might end up using them to reduce flooding issues at your low water crossing. So I'll go over that, and then I'll also show you how to get started assessing those land cover changes in ArcGIS. So this will be useful for you for your projects. Are there any questions before I get started on that? Great. So let's just do a quick overview of green infrastructure as it applies to this project. Again, as I mentioned, this isn't meant to be an extremely detailed overview of green infrastructure, but it is focused primarily on how you might use it for your projects. So deciding where to place green infrastructure, what you can replace, what land cover you can replace with green infrastructure, and how you might go about modeling it. Okay, so green infrastructure goes by many names. In the US, it's often called low impact development, or LID. But there'll be other acronyms in other places of the world. So for instance, in the UK, they call it SUDS. They have different names. In China, they call this sponge cities. So there's various names for it, but overall, the idea is to use changes to land cover and natural processes in order to improve stormwater quality and attempt to restore environmental flows. So restore pre-development hydrologic conditions. So there's three main types of green infrastructure that I'm going to be talking about and just briefly covering. The first are different types of natural pervious cover that can be used to replace impervious cover in urban areas. The second are different types of pervious pavements. And the third is rainwater harvesting. So I'll be covering each of these and kind of explaining how you might end up using it in your projects. Okay, so the first type, the first general type of green infrastructure is natural pervious cover. So essentially this consists of replacing some existing land cover with pervious area that can help to treat stormwater and reduce the flashiness of the flows or discharges occurring downstream. And there's a couple of basic technologies, one of the most common of which are rain gardens. These are also called bioretention cells. And they basically just consist of depressed areas in the landscape with plantings that are used to reduce runoff and also treat the stormwater. So these are often used to treat that first flush of contaminants. The water makes its way into these local depressions, and the contaminants can settle out and be treated by microbial life, as well as some of the vegetative life as well. So there's various ways that these can be connected to the drainage network and how you might think about modifying your existing land cover. So they can be installed in existing pervious areas, basically to increase the infiltration capacity of those already pervious areas. So if you go to the Waller Creek watershed, kind of the north area, for instance, you'll see many lawns that have these rain gardens installed. But you can also place them in impervious areas as well. So often you'll find them in or near parking lots. They can either be placed off to the side of parking lots where they'll have kind of an inlet structure designed to slow down the water. It pools in the rain garden. And you can also have them inside of parking lots as well. So when you're thinking about where to place land cover changes or green infrastructure, this is one way you might think about that. If you identify parking lots, rain gardens might be one option to try to reduce the amount of runoff coming off of those structures. There's also different ways that they can operate. And this is kind of just a continuum in terms of how much infiltration you're allowing versus how much water you're allowing to escape through an underdrain. So there's the full infiltration rain gardens, which are basically just a pit filled with, usually some sort of media like mulch with vegetative life growing out of it. And then you'll also have some kind of overflow structure in case the water gets too high, it can escape the rain garden. But apart from that, there's no kind of other outlet. And so basically the water just is meant to pool in these areas and stay there and infiltrate into the soil beneath. You can also have rain gardens that have an under-drain system, and this is to allow some of that water to escape. So it's acting kind of like a detention basin, but at a smaller scale. And this is, this helps prevent the rain gardens from overflowing. So you kind of get a balance between treatment and attenuation. Planter boxes are a similar idea, except the placement is slightly different. So these will be placed typically in sidewalks and more urbanized areas. Bioswales, very similar technology. It's basically a long and skinny rain garden. Unlike rain gardens where the water is meant to stay in place, these are typically locations where the water flows through and gets treated by the vegetative life in the bioswale as it passes through. And finally, you have green roofs. So these are typically rarer. we have some here. So this is a picture of the green roof at the Dell Med Center. Basically, it's just adding extra pervious area on top of the structure so that you can get, additional stormwater storage, additional peak flow attenuation, and so on. So as you'll see when we go through the different land cover uses, structures will often take up a large part of the footprint of your urban area. So this is one potential measure to target that can reduce the runoff coming from those areas. Note though that it's not typical to retrofit existing roofs with green roofs. This is typically done for new construction because you have to design the structure to be able to handle the extra weight of the soil and the water and also prevent leakage from, falling into the building beneath. So typically these are not, you don't usually have green roof retrofits. This is typically for new construction. Okay. Are there any questions on any of these technologies? How you might use it in your projects? So again, different technologies cater to different existing land uses with rain gardens, working, for instance, for parking lots or for existing pervious area, green roofs working for structural footprints and so on. So think about that when you go to work on your land cover design. Okay, the second category of green infrastructure I want to talk about is artificial pervious cover. So this is things like basically pervious pavements. So there's actually 3 different types, which I will go through. The first is permeable pavers. So these are basically a type of pavement consisting of interlocking bricks with gaps between the pavers that are filled with crushed aggregate. The water can flow over the top of the pavers and through those cracks where it can make its way into the soil underneath. So these are typically used for walkways, driveways, and smaller roads. Okay, so think about that when you're looking at your existing land cover usage. Aside from permeable pavers, there's also porous pavers in which you kind of have this interconnected lattice of pavement material. So in this case, it's mostly pervious area, and you have kind of this additional lattice of structural material to increase the structural resilience and prevent the ground from being eroded. These are mostly used for things like overflow parking, residential driveways, or pedestrian paths. You would not want to make a major road out of porous pavers. This would not work very well. But for things like different types of parking lots, driveways, and so on, this could be a good option for really increasing the infiltration capacity. And finally, we have pervious pavers. This is probably what you think of when you think about pervious pavement. In this case, the actual structure of the pavement is porous, which allows the water to go through. So this typically has a much greater infiltration capacity than the permeable pavers, i.e. the bricks. So you might see like up to 90% more infiltration than the permeable pavers. And these can be used for all kinds of different existing land uses. Okay, are there any questions on different types of pervious pavements? Questions on these? Okay, and the final category I want to talk about is rainwater harvesting. And basically this consists of just different barrels and tanks that you can attach to your buildings to capture the runoff from the rooftops. And as I mentioned, generally the structural footprint will be one of the largest land uses. So this can really help reduce your peak runoff in many cases. So the simplest form of rainwater harvesting are rain barrels. These will just be attached to the downspout of your structures. They can capture kind of that peak flow coming off of the roofs. Unlike the other measures, this also has different other uses as well. So for instance, you can use this to increase your water supply. You can use it to water gardens, plants. You can use it for gray water systems for your house if you want to provide water for a latrine or for your toilets, for instance. So it's really a multi-use technology. Cisterns are basically big rain barrels. You'll see these on many buildings in Austin, actually. So for instance, at Austin Community College, there's a lot of big cisterns, and these are used to attenuate runoff if you have a much larger structure. So overall, I just wanted to provide kind of a list of the different green infrastructure technologies you might be thinking of and where you could potentially place them. So as I mentioned, rain gardens would work well for parking lots, planter boxes for sidewalks. The different rainwater harvesting technologies would obviously work well for building structural footprint, and the different pervious pavement technologies have different uses depending on which type you want. So just wanted to provide that list for you. Finally, I have a list of resources that will be helpful for you, specifically for your final presentations and reports. The first is a stormwater BMP database. So BMP is kind of a general term meaning best management practice. This includes things like green infrastructure and low impact development. Let me just go ahead and take you there really quick. So the first link I provided is the stormwater BMP database. So the nice thing about this is it tells you lots of different types of stormwater BMP technology, but it actually provides unit costs for different stormwater BMPs, including green infrastructure, which will allow you to estimate the cost of any proposed designs for your project. So this is a really useful resource. And in previous semesters, I have had students use this pretty effectively in estimating their design costs. So this is a really useful link. The other link is, so you can find both of these under Canvas pages, green infrastructure / BMP links. The second link is this BMP modeling concepts and simulations guide. So this just provides some extra information if you're thinking about how to model different green infrastructure elements. Okay, are there any questions on any of these topics before I move on? Any questions on green infrastructure, low impact development? No? Oh, yep.
So with green roofs, are those typically full filtration where there's an under drain to carry the water away? I guess
yeah, there'll have to be some sort of under drain to carry the water away, or else it'll just overflow anyways once it gets full.
Oh, yeah.
But typically, yeah, it'll have a spout under drain.
Okay.
And there's different thicknesses as well. Okay, any other questions on green infrastructure and how you might use it? Has anyone taken a shot at doing your land cover designs yet, or thinking about how you might go about that? Okay. Cool. So I'll continue to kind of go around and help you out. Before I do that, though, I want to just go through the process of how you might go about estimating land cover changes using ArcGIS. So what I'm going to do is I'm going to first show you how you can basically take your land cover data and clip it to your contributing area of interest. And then I'm going to show you how you might estimate the individual land cover breakdown for your different subbasins. So this should take about 10 or so minutes. But I'm going to be doing this in ArcGIS. Okay. So first I'm going to start a new project. And I'm going to load in two different data sets. The first data set I'm going to load comes from the hydrologic spatial GIS data that you can get from FloodPro. And particularly, I'm going to be looking at Shoal Creek. Okay, so if I go under my GIS data, I'm going to open up shoal subbasins. So this will change depending on which watershed you have. I'm just going to look at Shoal Creek. I'm going to look at the subbasins. Okay, so this is Shoal Creek. It's the watershed. Okay, and let's say that our low water crossing is right here. So one way that we can just quickly estimate the contributing area is if we know where our low water crossing is, and let's just say it's right here, we can take this existing file, select all the subbasins that contribute to our low water crossing, go to data, layer from selection, and then we have an estimate of the contributing area for our low water crossing. So in this case, let's just say our low water crossing is right here. We can estimate what the contributing area is just using this GIS subbasin data set, which is available through FloodPro. Okay, the next thing I'm going to do is I'm going to load in the planimetrics data set that I showed you in the last class. So if I go to map, I go to my data, and I previously downloaded this planimetrics 2013 file. I'm going to go ahead and load this in. And again, this contains the land cover breakdown for every parcel in Austin. So it's quite a big data set. I'm going to zoom in so it doesn't take too long to load here. And I'm going to go, and again, I'm going to change the symbology so that it reflects the different land cover uses. So I'm going to do unique values, and I'm going to set the field to feature. So the first thing we would probably want to do is clip this planimetrics data to our watershed of interest. So to do that, what you can do is you can go to Analysis, Tools, and we're going to look up the clip tool. It's this extracts input features that overlay the clip features. Okay, so I'm going to go ahead and select clip. Our input is going to be the planimetrics data set. And the clip features is going to be our subbasin selection. If we run this, we will get the planimetrics data clipped to our watershed. Let's go ahead and let it run. And this shouldn't take too long. Oh, actually, I think this might actually take a while. So what I'm going to do is I actually pre-did this, and I'm just going to open up another. I'm going to open up another project with this clip already performed. So if I go to project, I'm going to go to land cover. And what you should get is something that looks like this. So this is the land covers clipped to our contributing area of interest. Okay, so the first thing you might think about is just figuring out what is the relative percentage of different land cover uses within the watershed, because we want to figure out what to target for land cover changes, right? So the first thing we can do is just try to estimate what the relative land cover use is by moving to our data set. Let's go click on it using right click and go to create chart. And let's create a chart of the different land uses in this basin. So to do that, I'm going to select our category is feature. So this is basically the different land uses, their names. For aggregation, I'm going to use sum. And for numeric fields, I'm going to use shape area. Okay, so this is basically summing up the land area associated with each one of those uses. Let's go ahead and let's take a look at what the biggest land uses are for our subcatchment. Now, note this is Shoal Creek. So this is a heavily urbanized watershed. It'll be a bit different from some of the other watersheds you have. But we see that the largest portion of land area is existing pervious area, basically. So the largest land cover use is currently pervious area. The second largest is structures. So this would be the building footprints, right? So that gives you an idea of what land cover you might want to target. So this could be either handled using a green roof, for instance, or a rainwater harvesting tank. So you may want to think about using that in your projects if structures are one of your biggest land uses. The third biggest land use, it's kind of a toss-up, but it appears the third biggest is basically paved roads. So this would be roadways. And the fourth biggest land use is paved parking. So those are the three primary land uses we'd want to target here: structures, roads, and parking lots. And we have different green infrastructure elements that are capable of handling each of those. Okay, are there any questions on this before I move on? Yes.
How to save that figure.
How to save the chart? I'm actually not, probably export.
Okay.
Okay. See if that works. And again, this land cover use will not be the same for all of your watersheds, especially if you have more rural land areas. Yes.
Good selection of our sheds.
Mm-hmm.
But we go to like for the water crossing. What about the water crossings at the top of this shed? And like I did the rectangle, but it's still like things that are below water crossing.
So I would probably just use only the ones that are upstream, like use the only ones that are for sure upstream. So again, this will be kind of an estimate or an approximation, but I think if it's in the middle of a subbasin, you can either, just consider the ones that are only upstream, or, if it's like halfway between, you might just say about half of the area in that subbasin contributes. So yeah, it'll be an estimate, but yeah, I'd say just do your best to estimate. Yes? Yes, so planimetrics you can find under Files, GIS, and then it'll be Planimetrics 2013. Now there's one more thing I wanted to show you before I let you go. So this subbasins data set, each one of these subbasins corresponds to a subbasin in the HEC-HMS model. So when you're figuring out how your land cover changes affect your flows, it's sometimes helpful to know what the land cover breakdown is within each subbasin and what changes to that land cover distribution, what changes that has on the curve number, for instance, or the amount of depression storage or the amount of impervious area. So it can often be important to know specifically within each subbasin what the land cover breakdown is. And to do that, I can teach you a cool trick. Within ArcGIS, there's a function to basically do exactly that. And that's called the spatial join. Has anyone heard of spatial joins? Okay. So what it's going to do is it's going to find basically for each of those subbasins, which polygons from the planimetrics intersect with that subbasin, and it's going to give us an output file where it has the breakdown. Basically, it'll give us the name of the subbasin for each polygon in the planimetrics file that land cover polygon is inside of. So to do that, I'm going to go to Tools. You can see it in the menu right here, but basically you can look up spatial join. This is a little bit of a complex feature just because there's a lot of things we need to select here. So for the target features, I'm going to select our clipped planimetrics data. So that is the one we're looking at right here. For the join features, I'm going to select, in this case, it's shoal subbasins. I think it's shoal subbasin selection, if I remember correctly. Yeah, so this is our selection from the shoal creek that is our contributing area. Let's see, for the rest of this, for join operation, I'm going to keep it 1-to-1. I'm going to keep all target features selected, and for match option, I'm going to select within. So it's going to look for the planimetrics polygons that are inside of each subbasin. Okay, and it's going to return this output feature, planimetrics 201 spatial join 2. Let's go ahead and run it. It might take a little bit for it to run. But because we clipped our data set, it shouldn't take too long here. All right, looks like it just finished up. Okay, and so our output feature is this file right here. Let me just turn off the existing planimetrics file. So this is our spatial join. You note that it looks the same as our previous planimetrics shapefile, but if we go into attribute table, we'll see that it has a couple additional columns. In particular, we now have this column that gives us the subbasin name that land cover parcel is located inside of. So if you go over here to the right in the attribute table, you'll see that it now has the subbasin, the name of the subbasin that land cover parcel is located inside of. So what we can do is, let's say we just want the polygons that are inside of subbasin shoal 27, which is the outlet subbasin. So what we can do is we can go to selection, select by attributes. We are going to select where subbasin name is equal to shoal 27. I'm going to hit apply. And note that it's selected the land cover parcels inside of that subbasin. Okay, are there any questions on that operation? Any questions on spatial joins, or just general questions about land cover, the land cover part of the project? Yes.
So say we've done this and we've got our new curve numbers for all of our subbasins. There's a fast way to move that into HGIS. So like all of the subbasins and make the new model.
How many subbasins do you have? A lot. I'm not exactly sure. I can try to look into it and figure out if there's a fast way to do it. Otherwise, you can just concentrate on some subset of them. But I think first just figure out the changing the land cover part, and then we can figure out how to translate that into HGIS most easily. Yeah, but good question. Thank you. Okay, any other questions on the land cover part of the project? Okay, well, with that, I will let you work for the rest of the class, and I will come around and help you as needed. Okay.